Hello everyone, this is the probability worksheet and we're going to start with the first question. It says that Petit picks up a card at random from 11 cards, okay, and does not replace it. You got to focus on that as well. Find the probability that she picks the letter L and the letter G. So second card is picked, so the letter L is going to be 1 over 11, 1 over 11, and the letter G is going to be 1 over 10. You realize that the total number decreases because it's without replacement. That's going to be 1 over 110. The letter E twice. We have how many E's? 1, 2, 3. So 3 out of 11 times 2 out of 10. This is going to give me 6 out of 110, okay? Two letters that are the same. So two letters that are the same, it can be E and another E, or it can be, which other two letters? So I think it's N, that's it. So it's either E, or N. So E and E was already calculated. Over here it's a 6 over 110 plus, it's the same for N and M because it's not the same actually because we have two N's. So the first probability is 2 over 11 times 1 over 10. That is going to give me 6 over 110 plus 2 over 110, which is 8 over 110. Okay, now it gets complicated here because now she picks a third card at random. Find the probability that the three letters are all the same. The only way to get the three letters the same is to get the first is an E, second is an E, and third is an E. So that is 3 out of 11 times 2 out of 10 times 1 out of 9. Okay? This is going to give me 3 times 2 times 1 is a 6. 11 times 10 times 9 is a 990. Okay? Again, I'm not going to bother myself to simplify. That's totally fine. Do not include, the next question, do not include a letter E. So some of you might think about it, and this is that 1 minus the previous answer would give you the wanted answer here. But no, do not include the letter E means that the first is not E, the second is not E, and the third is not E. Okay? So if we have 11 total, 3 of them are E's, so 11 minus 3 is going to be an 8. So not an E is 8 out of 11 times 7 out of 10 times 6 out of 9. Denominator is 990. 8 times 7 times 6. 336. Okay? Okay, include exactly 2 letters that are the same. So when we go, we have 3 E's and 2 N's. It only applies to these 2 letters because I don't think I have any other repeated letter. So 2 letters that are the same can be exactly 2 letters that are the same. So it can be E, E, and not E. All right? E, E, and not an E. And I'm going to multiply this by 3 because it's going to have 3 orders, okay? 3 different combinations. It can be E first, not E, then E last. And it can also be N, and not N. And I'm going to multiply this by 3 as well, all right? So when we get the first probability, it's going to be E is 3 out of 11. The second E is 2 out of 10. And the remainder is going to be not an E, which is 8 out of 9. You can ask me, like, why is it an 8? I would have to go back here and explain it to you. So if I took E first, this is out. E second, this is out. How many letters are not E's? So 1, 2, 3, 4, 5, 6, 7, 8. That's my explanation for it, divided by the total. So I'm going to take this, where am I? And I'm going to take this and multiply it by 3, okay? So 3 times 2 times 8 times 3 again. This is 144 and 990. Over here, n is 2 out of 11. Second n is 1 out of 10. And the remainder is going to be something out of 9, which is also 8 out of 9. And multiply this by 3. Okay? I don't think it's an 8 out of 9, though. I think it's a 9 out of 9. The last one here. Not an n, because not an n, if I took, going back here, let me just erase these. If the first, I took an n, and I took the other n, how many remaining? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 9 out of 9. Okay, of course the 9 out of 9, they cancel out. So 2 times 3 is a 6. And 11 times 10 is a 110. Okay? Then finally you add up these together. So 198 over 990. And now going to question number 2, I'm just going to label it here. Now it says that a box contains 3 red, 2 blue, 4 green. 3 plus 2 is 5, 5 plus 4 is 9 is your total. Rat chooses 2 pencils at random without replacement. Both red, please. Follow this technique. Red and red means that the first is red, 3 out of 9, 2 out of 8. 6 out of 72. Both are the same color, so it can be red, red, blue, blue, or green, green. Red, red is 6 out of 72. Plus, blue, blue is going to be 2 out of 9, 1 out of 8. Green, green would be 4 out of 9, 3 out of 8. That's why it's a 3 marks question. 6 out of 72 plus 2 out of 72 plus 12 out of 72. So it's out of 72, so 12, 8 is 20 out of 72. Exactly one of the 2 pencils is green. Okay, exactly one of the 2 pencils is green. So it can be green and, I'm not going to say green and red or green and blue. No, green and not green. That's a skill that you need to understand or acquire. Times 2, because it can be this way or that way. So the first is green. Back to how many greens? 4 greens. So 4 out of 9. Okay, times not green. How many are not green here? Which is blue and red, 5. But it's going to be a 5 out of 8 multiplied by 2. That's 72. 4 times 5 is 20. 20 times 2 is a 40. We're going to move on to question number 3. And in question number 3, it gives us that spinners, scores, probabilities are given down here. Work out the probability that on one spin the score is 2 or 3. So 2 is 0.2. Or means a plus. 3 is a 0.4. That's going to give me a 0.6. In 5,000 spins, that's relative frequency. How many times would you expect to score 4 with this spinner? 4 is a 0.3 times 5,000. That's a 1,500 times. Work out the probability of scoring 1 on the first spin and 4 on the second spin. They gave you order, so 1 on the first, 4 on the second. This is going to give you 0.1 times 4 is 0.3, and that is 0.03. That's second part of this question. Says that in a bag there are 7 red, 5 blue. From a bag, a disc is chosen at random and not replaced. A second disc is then chosen at random. Work out the probability that at least one of the discs is red. At least one of the discs is red. So here, let me tell you something. So it can be red, 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 blue, blue, red, blue, blue. When they say that at least, and this is always with this type of questions, we use something known as reverse probability. And in reverse probability, at least one red, it can either be this, this, this. So instead of calculating the 3, we are going to find blue, blue, and then say 1 minus blue, blue would give me my answer. Blue, blue is going to be 5 over 12 times, not replaced, 4 over 11, 20 divided by 132. So 20 divided by 132, 20 divided by 132, 1 minus answer, 28 over 33. That's a simplified answer because I used the calculator. All right. Moving on to the next question. This is question number, let me remember, 4. So let me label it here. Question number 4. So here it says that letters nation. A card is chosen at random. Write down the probability that it has the letter T. 1 T only. So 1 over 1, 2, 3, 4, 5, 6. It does not have the letter N. So 1, 2, 3, 4. 4 over 6. Lara chooses a card at random, replaces it, and chooses a card again. Calculate the probability that only one of the cards chooses has the letter N printed on it. So you're going to say the first is N, and the first is N, and the second is not N, multiplied by 2 again because of the order of operations here. N is going to be 2 out of 6 times not an N is going to be 4 out of 5. Then I'm going to multiply that by 2. That's going to give me over 30. 2 times 4 is 8. That's a 16 over 30. That is the answer for this question. Jacob chooses a card at random and does not replace it. He continues until he chooses a card with the letter N printed on it. Find the probability that this happens when he chooses the 4th card. 4th card means that the first card is not N. Second is not N. Third is not N. The 4th is N. Okay? So without replacement, not N. How many cards without an N? It's 4 cards, right? 1, 2, 3, 4 again. So 4 out of 6 times 3 out of 5 times 2 out of 4 times 2 out of 3, because 2 N's are remaining. So 4 times 3 is 12, 12 times 2 is 24, that's a 48 divided by 30, 120, 360. That was quick mathematics. Alright, in this coming question, I think this is, if I'm not mistaken, question number 5. So it says Kaya plays a game. The game involves throwing a coin onto a circular board, and then the scores are given. So we gotta find x fast. We need to know that all the probabilities added, they give us 1. So to find x, we say x plus 0.2, 0.3, 0.45 equals to 1. I'm gonna quickly use my calculator. Plus 0.5 and minus 1, so that is a 0.05. Now, Kaya throws a coin 50 times. Work out the expected number of times she scores 5 points. We gotta go 5 points is 0.3. So 0.3 multiplied by 50, 15 times. Kaya throws a coin 2 times. 2 times now combined events. Okay, this is when you start adding, subtract, multiplying, etc. Calculate the probability that she scores either 5 or 4 with her first throw. 5, not 5 or 4, 5 or 0. So 5 or 0, 0.3 and 0.45. So 0.3 plus 0.45. That is going to give me 0.75. She scores 0 with the first, 5 with the second. So 0 with the first and 5 with the second. Again, and means multiplication. So 0 is 0.45 and 5 is going to be 0.3. So 0.45 times 0.3, that's 0.135. All right. Greta has, oh, that's the end of the question. Interesting. So this is going to be question 5. Then let's go to question number 6. Gareth has 8 sweets in a bag. 4 sweets are orange flavored, 3 sweets are lemon, 1 sweet is strawberry. He chooses 2 of the sweets at random, 2 of them. Find the probability that the 2 sweets have different flavors. 2 sweets have different flavors. I can do this in multiple ways, but I'm going to do this again using reverse probability. And I'm going to say that if 2 sweets have the same flavor, it's going to be, let's say, orange, or lemon, or strawberry. Okay, find 2 sweets of different flavors. So same flavors is going to be 4 out of 8 multiplied by 3 out of 7 plus lemon and lemon, 3 out of 8 times 2 out of 7 plus strawberry, that's impossible. So 1 out of 8 times 0 out of 7, it cancels out this. Again, bear with me. So 12 out of 56, 6 out of 56, that is 18 out of 56. That is the same flavor. Now different flavors goes the other way around. So 1 minus 18 out of 56. Okay, so let me see. 6 minus 18, 38 out of 56, and that is your answer. Gareth now chooses a 3rd sweet. Find the probability that none of the 3 sweets is lemon flavored. So again, none of them. So not lemon, not lemon, not lemon. Again, not lemon can be orange, which is 4, or strawberry, 5. So not lemon is 5 sweets. So 5 out of 8 times 4 out of 7 times 3 out of 6. 5 times 4 times 3, 60. 3, 3, 6. And starting question number 8. So it says that can one plays a board game? He has 2 dice, 1 to 6. He throw both of them. So if he threw 4 and 3, he would move 7 spaces. So what is the probability of him moving 2 spaces in his next throw? 2 spaces means he's going to get 1 and 1. Okay, 1 and 1, 1 in the first dice, which is going to be 1 over 6. And in the second is going to be 1 over 6. That is a 1 over 36. 10 spaces. 10 spaces can be 5 and 5. Or it can be 6 and 4 multiplied by 2. Remember, because we can just change the order of that. That's it. So 5 and 5, 6 and 4. 5 and 5 would be 1 over 6 times 1 over 6. That's a 1 over 36. Plus 6 and 4, 1 over 6 times another 1 over 6 times 2. Which is a 2 over 36. That is a 3 over 36, a final answer. Going to question number 9. A box contains 6 red, 8 blue. Okay, pencil is chosen at random and not replaced. So 6 red, this means that it's going to be 8 over 14 here. Not replaced means that this is going to be 5 over 13. If I picked a blue, it's going to be 7 over 13, 6 over 13. Calculate the probability that both pencils are red, so it's a 6 over 14 times a 5 over 13. You go this branch times this branch would give you the red and red. So 6 times 5 is a 30. 14 times 13, that's a calculator here, 182. At least one of the pencils is red. One of the pencils is red, so remember that they're red and blue. So we have red, 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 blue, blue, red, blue, blue. Okay, so at least one of the pencils, so it can be this one, or this one, except this one. So I'm going to use reverse probability again. Where I find blue, blue, then I say 1 minus blue, blue. So let me find blue, blue first. Blue, blue is going to be, going back to the tree diagram, 8 over 14 times 7 over 13. 8 over 14 times 7 over 13. 8 times 7 is 56 over 182. So then 1 minus 56 over 182, 126 over 182. Okay. So starting the next question here, it says that Samira takes part in 2 charity runs. The probability that she finishes each run is 0.8. Find the probability that Samira finishes at least one run. Finishes at least one run again. I'm gonna say finishes, 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 does not finish, does not finish, and finishes, does not finish, does not finish. So finishes at least one run lies over here. Again, as I always do, I'm just gonna use reverse probability where I find this, which is 0.2 times 0.2. That's a 0.04. So 1 minus 0.04 is a 0.96. Instead of going all through these, I'm just going to do it that way. Question 11 says that the probability that a plant will produce flowers is 7 over 8. Okay, 7 over 8. No flowers is a 1 over 8 because they're add up to 1. If the plant produces flowers, the probability that the flower is red is a 3 out of 4. Yellow is a 1 out of 4. Calculate the probability that the plant chosen at random will produce red flowers. So red flowers, I'm not going to go to 3 over 4? No, because I need to go through this branch, then this branch. So 7 over 8 times 3 over 4, 21 over 32. Then, two plants are chosen at random. Calculate the probability that both will produce red flowers. So, coming to the previous question, the probability that a plant chosen will produce red flowers is a 21 over 32. Okay? So, if two plants are chosen at random, this is when I say 21 over 32 times 21 over 32. So this is going to give me 21 times 21, and that is 441. 32 times 32 is 1024. Okay. After that, Alphonse buys 200 of these plants. Calculate the number of plants that are expected to produce flowers. Back to the expectation to produce flowers, which is a 7 over 8. So 7 over 8 times 200, and that is going to give me 175. Gabriel has 1,575 plants with red flowers. Estimate the total number of plants that Gabriel has with red flowers. So I need to go back to 21 over 32. That's the probability of getting a red flower. So the probability of getting a red flower is 21 over 32 times the total is supposed to give me 1,575. The total would be, I'm just going to cross multiply, 1,575 times 32 divided by 21, 2,400. 2,400. Now, starting question number 12, it says that train stops at station A, then station B. If the train is late, probability that it's late to B is 0.9. If the train is not late at station A, the probability that it's late at station B is 0.2. Okay, if it's not late at station A, which is 0.7, the probability that it's late at station B is 0.2. Now I need to just complete these, and that's it. Then find the probability that the train is late at one or both stations. Late at one or both stations. So late at both stations, late at one station, not late and late, not late, not late. So that's the thing that I don't want again. So that's what I'm going to do. Not late and not late is 0.7 times 0.8, 0.56. 1 minus 0.56 is going to be 0.44. The train makes 250 journeys. Find the number of journeys that the train is expected to be late at one or both stations. So I'm going to take the 0.44 multiplied by 250. 250 times 0.44, and that is 110 times. The train continues to station C. The probability that it's late at all three stations is 0.27. Describe briefly what is this probability shows. So late and late is 0.3 times 0.9, which is 0.27. Okay, so 0.3 times 0.9 is 0.27, and this is lateness in just two stations, which means that in the third station it's going to certainly be late to give me the same 0.27. So this means that it will certainly be late at the third station. Okay, 0.3 times 0.9 times 1 equals to 0.27. Okay, finally the last question, which is going to be Young and Arevan completed triathlon. The probability that Young finishes is 3/5, Arevan finishes is 2/3. Which of them is more likely to finish? So I'm just going to use equivalent fractions here. I'm going to multiply this by 3 and 3, that's a 9/15. Multiply this by 5 and 5, that's a 10/15. Which one is more likely to finish? It's Arevan, because 10/15 is greater than 9/15. Find the probability that they both finish. Both finish means that Young finishes and Arevan finishes. So that is a 6/15. Only one of them finishes. So I'm going to say Young finishes is 3/5. Arevan does not finish is 1/3, because him finishing is 2/3, not finishing is 1/3. Or Young not finishing is 2/5. Arevan finishes is 2/3. That is going to give me 3/15 plus 4/15, which is a 7/15. Moving on. Let's complete this tree diagram. So 3/5, that's going to give me 2/5 here. 6/7, that's a 1/7. 6/7, that's a 1/7. That's a 3/10. 3/10. 3/10. 3/10. Calculate the probability that Young finishes all three of the races. So 3/5 times 6/7 times 7/10. That's 350 total, and 3 times 6 times 7, 126. Calculate the probability that Young finishes at least one of his races. At least one of his races. I'm gonna go with not finish, not finish, not finish, then 1 minus answer. So 2/5 times 1/7 times 3/10. That is going to give me 6/350. And 1 minus 6/350 is going to be 344/350. And thank you very much, everybody. Then the second letter, which is a G. How many G's do we have? I think it's only one G as well. It's 1/10. This would give me 1/110. The letter E twice. The letter E twice is going to be, for the first letter E, because we have two of them, we're going to say 2/11. And the second E is going to be 1/10. This is going. All right, back to this video, and just want to tell you that this is my signature here, and thanks. Okay, question 13. It's about weather, and I'm just if the weather is fine, the probability that Carlos is late arriving to school is 1/10. So fine, 1/10. Not late would be 9/10. Not fine is 1/4. So if the weather is not fine, the probability that he is late is 1/3. 1/3, that would be 2/3. In a school day of 60 days, find the number of days that the weather is expected to be fine. So 60 times 3/4, which is going to be 45. Find the probability that the weather is fine and Carlos is late arriving to school. So weather is fine. Carlos is late arriving to school. That is a 3 over 40. Find the probability that Carlos is not late to school. Not late can either be fine, then not late, which is 3 over 4 times 9 over 10, or not fine and not late, which is 1 over 4 times 2 over 3. That is going to give me 27 over 40 plus 2 over 12. Okay? 27 over 40 plus 2 over 12, 101 over 20 over 120. Find the probability that the weather is not fine on at least one day in a school week of 5 days. At least one day which is not fine. So I'm gonna say that let it be fine for 5 days. Fine for 5 days is going to be, fine is 3 over 4. So 3 over 4 to the power of 5, which is going to give me 3 over 4 to the power of 5. 243 over 1024, then 1 minus 243 over 1024, because it's reverse probability. 781 over 1024, and that